With section 1.5, we're continuing our investigation of functions. So we're looking at linear functions and modeling, which just means looking at real-world applications. So first we are talking about the point slope formula. Point slope is y minus y sub 1 equals m times x minus x sub 1. So if we have a point, x sub 1, y sub 1, and the slope m, then that will give us the point slope formula. So for example 1, we have the point, negative 4, 2, and a slope of 2, and we're going to plug in to our point slope formula. So we've got y minus 2 was the y value of our point. Our slope is 2, and x minus negative 4 is the x value of our point. So just simplify a little bit by saying x plus 4, and that is our point slope form. It says also write it in slope-intercept form. So basically all we're going to do is take this equation that's in point slope form and solve it for y. So first distribute the 2 and then add the 2 that's on the side with the y there, and we got y equals 2x plus 10. For the second example, we want to do the same thing. So y minus our y value equals the slope times x minus our x value. And so we could leave this as y minus 0, or we could just, since y minus 0 is just y, we could change it, and there is our point slope form. So to write it in slope-intercept form, all we need to do is distribute the negative 2/3. For example 3, it says to write an equation in point slope form that passes through these 2 points. So this time we have 2 points instead of a point and a slope. But we know that we can find the slope if we have 2 points, right? So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And so our slope is 5 over negative 1, or negative 5. And then we can write this in point slope form using one of the points and the slope that we've just found. So y minus our y value equals our slope times x minus our x value. And, oh, that's not a 5, that's a 4. So we've got y plus 4 equals negative 5 times x plus 1. So to write it in slope-intercept form, again, we just solve for y. So add or subtract 4 from both sides, and we've got y equals negative 5x minus 9. This one, it says we want to write the line in point slope form or slope intercept form that passes through the point 2, 3, and the slope is undefined. Well, if you'll remember, an undefined line does not have a slope. There is no slope. An undefined line is vertical. just saying x equals whatever the point is. So in this case, it's just x equals the x value of our point, 2. It's just a vertical line going through x equals 2. And that's it. Parallel and perpendicular. Parallel lines have the same slope. Perpendicular lines have slopes that are, I call it opposite reciprocals. Okay, so what that means is opposite, meaning if the original slope is positive, then the perpendicular is going to be negative, or if the original is negative, the perpendicular is going to be positive. And reciprocal means you flip the fraction. So m over 1 would become 1 over m. So for these three, we're going to write down the parallel slope and the perpendicular. So for the first one, the original slope is negative 3/8. So the slope of the parallel line is negative 3/8. The slope of the perpendicular line, opposite of negative, is positive, and then flip the fraction. So the perpendicular line slope will be 8/3. For number 6, the slope is 20, and so the parallel line slope will also be 20. The perpendicular line slope will be negative, and this was 20 over 1, right? So to flip that, we have 1 over 20. And last, with slope of 0, the parallel line will also have a slope of 0. But if we flip that, that's 1 over 0. That's not possible, right? So remember that a line with a slope of 0 is a horizontal line. What's perpendicular to a horizontal line? A vertical line. So a perpendicular line to the horizontal is vertical, and its slope is, well, there's not one. There is no slope. For this next one, we're going to find the equation of the line that is parallel to this line that goes through this point. So first we need to solve this equation for y. So we got y equals 3x plus 4. And we add 3x to both sides. And we need to discover, well, what's the slope of that line? It's 3. So the slope of the parallel line will also be 3. And so we're going to use the slope of 3 and the point negative 1, 2 to write the equation of our line. So y minus y sub 1 equals m times x minus x sub 1. And I'm going to go ahead and write this in slope-intercept form. So we're going to distribute the 3 and add 2. So the slope, so the line parallel to y equals 3x plus 4 is y equals 3x plus 5. For this one, we want the equation of the line that's perpendicular to 2y plus 5x equals 10 that goes through the point 6, 8. So the first thing we need to do is find the slope of our line 2y plus 5x equals 10. So we're going to solve it for y, so subtract 5x from both sides and divide by 2. So the slope of this line is negative 5/2. That means the slope of the perpendicular line is going to be positive 2/5. And then we plug in with our point. So y minus 8 equals our slope of 2/5 times x minus 6. And then I'm going to solve it for y, so distribute the 2/5. And let's see, that was supposed to be a minus there. So, and add 8. So, y equals 2/5 x plus 5.6. The next concept is on modeling linear functions. So for this one, we want to find a function that will represent our data. It says the local hardware store charges $28 to rent a carpet cleaning machine for 24 hours and $10.98 for each medium-sized bottle of rug shampoo. Write a linear function that represents the cost of renting the machine for X days along with 2 bottles of rug shampoo. So we're letting X be the number of days we're going to rent the machine. So it says S is the cost for us. So S of X is, the machine is $28 per day. So 28 times X plus we're getting 2 bottles of shampoo, and we know that that's a fixed amount there. So it's 28x plus 21.96. For part B, it wants us to find S of 2. So, to find S of 2, we're going to plug in 2 for X. And that gives us 77.96. Now, what does that mean in the context of this problem? Well, X was the number of days, right? So, the machine costs $77.96 to rent for 2 days with the two bottles of shampoo. Okay, but this 2 is the number of days. So, a cost function, as you've already seen, is the cost of the item, the fixed cost of the item, plus the cost per item. Revenue is the amount of money that you make selling something. So it's however much you sell it for times the price of the item, or times how many items. And then the linear profit then is how much you charge minus how much it costs to you. So looking at that example here, it says Alina is starting a summer business power washing home driveways and sidewalks. She will charge $35 to pressure clean a driveway and the sidewalk in front of a house. Her startup costs include her initial purchase of a power washer, which was $330, and a fee of $2 per house she has to pay to the Homeowners Association for using the water. So a cost function for Alina would be the fixed cost of her power washer plus $2 for each house that she washes. So and that's letting X be the number of houses. So the cost to her is $330 plus 2X. The revenue, how much money she's going to be paid, is she gets $35 for each house. So $35 times X. Therefore, her profit will be her revenue, the amount she charges, minus the cost it is to her. So we've got her revenue, which she gets $35 for each house, minus the cost to her was $330 for her machine and $2 for each house. So if we distribute our negative here, then her profit function is 33x minus 330. Part D asks us, how much profit will Alina make if she washes 15 homes? So remember, X was the number of homes. So we're going to plug in, we're going to let X is going to be 15. So we're finding P of 15. So multiply and add, and we get that she will profit $165 by cleaning 15 homes. And part E asks, how many homes would she have to wash to make $330? So this time we're solving for X. We want to know how many homes. So $330 is her profit. And we want to solve for X. So add 330 to both sides. And divide by 33. She would have to wash 20 homes, pressure wash 20 homes, to get $330. Our last concept today is creating a linear regression model. So what we use is a program on the computer that you download that's called Desmos. Well, actually, you just use it online. And so here is a little example of how you would use Desmos. And I may make you a video of this too. We'll just see how it goes. But it says determine the equation for the least squares regression line for the given data. So what we've got here is we've got a table with some data, and it's been plotted to make what we call a scatter plot. Okay? And we want the line that goes through these points that most accurately represents these points. So in Desmos, what we do is we go to the little plus sign, and you're going to create an expression. And then, or no, you're not. First, you're going to create a table. And so you can put your x values under here and your y values under here. And you can see it plots the scatter plot over here for you to the right. So how do you find the best fit line or the line of regression? Well, I've got the same thing on here twice, don't I? Oh well, ignore one of them. So that's not supposed to be there. Do I have? Yeah, I do. Okay. So you're going to go down below the table and you're going to type y sub 1 and then this little squiggly thing, m times x sub 1 plus b. And that's going to find the regression line for you. Now notice to type y sub 1, oh, I see why I did that now. It is different. So, here's why. To type y sub 1, you write y and then you select this, you press on the ABC to get your y value. And then you press this button here and it'll let you put a subscript. And so you'll press that, go back to your numbers and select 1. Okay? So that gives you y sub 1. To get the little squiggle, then you go over to your text box again, and there's your squiggle. Then after that, you'll get m, and then you're going to do the same thing you did for x sub 1 as you did for y sub 1. So x subscript 1, and then plus b. When you do that, see how I've typed it in right here? Then you get values for m and b. And so the equation of the line would be 0. I'm just going to go to 3 decimal places, 967x, because that's the slope, plus your y-intercept 0.3. And you can see they've graphed it for you, and that is the line that as close as possible goes through those points. So that is the end of section 1.5.